Hello everyone. In this video, I will explain how to write context-free grammar for regular languages. Remember that every regular language is a context-free language. We can clearly see the diagram. See this diagram. When diagram says that the context-free grammar language is containing the regular language, so it means that regular languages are nothing else but context-free language. And if it is a context-free language, we are able to write the context-free grammar for regular language. So let me take any example. Start with this. If we have language sigma is 0 and 1, 0 raised to the power n, where n is greater than equal to 0, we need to write, suppose I want to write a context-free grammar for this, what I will do, I will start with the symbol s, and we have what? See, the language says that string is made up of 0, any number of zeros, including the null, that is smallest string is null. So 0s and this null. That is, s can be replaced by either 0 followed by s or a null. We can clearly see the derivation. If I have some string 0 raised to the power 3, I can derive it using this s. S is replaced by, that is derived 0s, and again this s will be 0s, again this s will be 0s, and finally this s is replaced by null, so I'll get 3 zeros. And similarly, you can derive any string of the kind 0 raised to the power n for any value of n greater than equal to 0. Now suppose we have the next example. L is 0, 1 raised to the power n. That is, we have set of the languages of made up of string null, because n is greater than equal to 0 is allowed. Null is there, 0, 1. The string is 0, 1, 0, 1, or string is 0, 1, 0, 1, 0, 1, and so on. Now we need to write a context-free grammar for this language. It will be like 0, 1 raised to the power n. What here I will do, I will take a variable a and I will write it as as, and this s can be replaced by null because the smallest possible string is null. And how I will replace this a with? A is nothing else but 0, 1. So in place of a, I could have written like this also. S is 0, 1, s, or null. So for simplicity, I have written this variable a, and this variable a is 0, 1. So we can derive any string of this form from the given context-free grammar. I hope this is clear. Take the next example. 0, 1 or 1, 0 whole raised to the power n. And remember that n is greater than equal to 0. It means null string is allowed. So therefore, here I'll take two variables. Say one variable is 0, 1. The another variable is 1, 0. And then we have the start symbol s, which is either take one more step, take one more variable c, which is either a or b. And we need to have that start symbol s. S is c, s, or null. This is the context-free grammar for the given language. We can clearly see we have a is 0, 1, b is 1, 0. The variable c is either a or b, and the start symbol is the variable c or s. Now suppose if we have some string of the form 1, 0, 1, 0. We can have such kind of string from the given language, and I want to derive this string by using the grammar. I will start with s, cs. Now what is c? C is either a or b. So I will replace this C, what we want 1 0. So I will replace this C with B and then BS. Now there are two variables. Again, take the leftmost derivation. I am following the leftmost derivation. I'll be discussing this, the leftmost derivation and the rightmost derivation. The leftmost derivation is that when we have more than one variable in the derivation process, we always pick the leftmost variable to be replaced by some another symbol or non-terminal symbol. Now this B is what? 1 0. I'll change this 1 0 S. Now this S is again replaced by, now we have only one variable in this particular derivation. So I will replace this S with CS. 1 0 CS. Again, there are two variables. Take the leftmost. CS. C is again replaced by B. And then followed by S. In the next step, what I can do, I can take, because now we have already got that string 1010 in the derivation process. So eventually this S will be replaced by a null, this null. So we have 1010. Now I hope this context-free grammar is clear to all of you. Now we can see this one. If the language is 01 raised to the power n followed by 00 raised to the power n for some n greater than equal to 0. Instead of taking this n, let me take this as m for some n greater than equal to 0 and m greater than equal to 0. I did this because we are working on the regular languages. So 01 raised to the power n, 00 raised to the power m for some n greater than equal to 0, m is greater than equal to 0. Now we will make the context-free grammar. Let me take any variable a and put it as 01. Means the variable a is replaced by 01. The another variable b is replaced by 00. And then let me take one more variable s1. S1 has to repeat this 01. See, repeat this 01. So 01, that is a s1. I can write a s1. Also remember that this n is greater than equal to 0 means we can have 01 raised to the power 0, that will make it null. So eventually this will be replaced by, this s1 can be replaced by null. Similarly, the another 00 raised to the power m, for this I can write b is replaced by 00 and then take some another symbol s2 and write this as, we need to repeat this b any number of time including null time. Now one more symbol has to be there, that is s. So s is nothing else but s1 followed by s2. So we have the grammar, context-free grammar for the given language as this. I hope this is clear. 01, for this 01 I have taken a variable a is replaced by 01. For b we have 00, b is replaced by 00. Now remember that 01 has to be repeated n times including n is greater than equal to 0, that is null time. So for repetition for the loop I have taken this s1 is replaced by as1 for null. For S2, I have taken B S2. B is 00. We need to repeat this 00 n number of times, including null times. So B S2 or null. And then finally, the start symbol S will have S1 followed by S2. Now see this language, the regular language again, 011 plus 1 raised to the power n followed by 01 whole raised to the power m for some n greater than equal to 0, m greater than equal to 0. The regular expression for this language is given as 011 plus 1 whole star 01 whole star. Now what I will do, let me take this part of the regular expression and we need to write a context-free grammar for this expression. Take this. Let me take any variable. A can be written as 0, 1, or 1. And we need to repeat this n number of times. So I can write this S1, A, S1, or null. Because null, why I'm putting null? Because this is a star. Star means we can have n. This n can go up to 0. Similarly, for the next expression, that is 0, 1 whole raised to the power n, what I have taken this for this expression, take another variable b, which is 0, 1, and take variable s2, that is repeating this 0, 1 n number of times, including null times. 0s2, bs2, or null. Now, what we need to do, we need to perform the concatenation of S1 and S2 to get the final answer. So therefore, the context-free grammar would be like this. Final context-free grammar for the given language would be like this. S is nothing else but S1 followed by S2. Just copy all these here. S1 is nothing else but AS1 or null. What is A? A is 0, 1, 1 or 1. Next, what is S2? S2 is BS2 or null. And what is B? B is nothing else but 0, 1. So I hope this example is clear to all of you how to write a context-free grammar for the given language. We will check more example. Now we have this example, a raised to the power n, b raised to the power m. For some n greater than equal to 0, m greater than equal to 0, that is the regular expression is a star, b star. The context-free grammar would be start from any s. Suppose I write this a and b. What is a? A is nothing else but repetition of this small a. And this is star means it can go up to null. So I can write this null. Similarly, the variable b is nothing else but the repetition, that is loop, that will keep adding small b into the string. So this bb or null. Why null? Because it can go up to 0. So the context-free grammar for a star, b star is this. Take the next example. Suppose I have this a raised to the power n, b raised to the power m, where n and m this time is not equal to 0. Means the smallest value of n has to be 1, smallest value of m has to be 1. So we'll start with this. All the context-free grammar would remain same as the previous example with small difference. Instead of taking null value, see this, instead of taking this null value, for a, I will write small a here. For this b variable, I'll take small b here. So the grammar would be like this. Or a, b, or b. That's it. So the smallest possible string I can generate from this grammar is either AB. This is the smallest possible string we can have. We can clearly see that suppose if I start with the start symbol AB, take the leftmost derivation, replace this A with small a from this place, and this b can be replaced by small b from this place. So the smallest string I will have is AB. I cannot have a null string in this case because the grammar is correctly written for this language. Let me take any other example. Now this is again the language, which is regular language, and I am writing context-free grammar for this language, A double B plus B whole star. So again the same process, we can take some variable A and I can take A double B or B. Remember that we need to repeat this expression n number of times including null. So I will write that S is AS or null. That's it. So this is the simpler one. What about this? Are you all able to write the context-free grammar for this language? Please try. For those who are not able to, I am writing for you context-free grammar for this A star double B. This A has to repeat it n number of times and then ending with two B's. So what I will write this as, suppose A and double B. And this capital A is nothing else but it has to repeat small a n number of time including a null time. So I will write this as this or null. Now suppose if I ask you to derive a string a cube double b from the given context-free grammar. Start from this. The variable b, the variable a is replaced by AA or followed by double B, and then this A is replaced by again AA. Again this A is replaced by, eventually this A is replaced by null. This null is there, so I have triple A followed by a double B. I hope this example is also clear. Now take this example. It says that we have some string, that is a language of string, any combination of 0 and 1, but the restriction is on the length of the string. The length has to be odd. Length of W is to be odd. We can clearly see this is a regular language and we have this automata in front of us. This automata, finite automata. The regular expression is 0 plus 1 raised to the power 2 whole star followed by either 0 and 1 to make it odd. So let me write the context-free grammar for this particular example. Remember that what is the restriction? The only restriction is on the length. Otherwise there is no fixed pattern. We can have the sigma is given as 0 or 1. That is, we can have a string starting with a 0, we can have a string starting with a 1, starting with ending with 0, ending with 1, in between any possible combination of 0 and 1. So we need to write the grammar only with a restriction of on the length of the string. So I will write this as, this is 1a, string can start with 1 or string can start with 0. Now this A can be replaced by either 0, S, or it can be replaced by 1S. And this A can also replace by null. That's it. Now see this example. If I have some string of length 2, suppose I have a string of length 2 means, suppose if I take double 1, check if we are able to generate this double 1. Now this is an even length string. If I take start with as 1a, now I want this a to be replaced by 1s because the next symbol I want is 1. So I will replace this a with 1s. Now this s cannot be replaced by any 1a. If I take this 1a, it will become triple a. If I take 0a, it will become 110 and this string will become length of 3. And we cannot directly convert this s to null because we do not have null replacement for s. So we are not able to generate this length of 2 strings. Suppose if I take this as triple 1 Repeat the process. 1A. This A is replaced by 1S. Now this S is replaced by 1A. Now this A is replaced by null. So I get 111. So by this context-free grammar, I am able to generate only the strings of length, that is odd length. Now take this example where we have the same example. The only difference is that the restriction is on the length of the string. We want even length string in this case. So I'll start with S. This time I'll just shift the value of null, 1A or 0A, and this A is 0S or 1S, same as the previous. Just let me show you that. Same as the previous one. The only difference is that what I will do, instead of writing null here, I will put this null with S to make sure that the string is always even length string. So I will write null here. In this case, I will always be able to generate the even length string. Even length string, for example, if I have this string, this is an even length string. So let me start with the derivation. S is replaced by 1A. Again, this A is replaced by, I need 1 again. So I will replace this A with 1S. Again, I want a 1. One more 1 is there. So I will replace this S with 1A. Again, this A has to be replaced with 0. So I'll write this as 0S from here. And from eventually this S will be replaced by null. This time I can take a null from here. So I get 110. That is string of even length. Now try some string which is an odd length. Suppose if I have string 110, what will happen in this case? 1A, 1S. Now this S is replaced by again 1A. Now what next? If I take this A replaced by 0S, I'll get, oh sorry, instead of taking this S as 1A, I will take it as 0A because I want a 0. Now this, to replace this A, I need to pick either 0S or 1S, which I don't want because the string is of odd length, that is only 3 characters long. So we are stuck here. We are not able to generate 110 from the given grammar. So if you have written the correct grammar, you will be able to generate only the strings that belong to the language. I hope this video gives you idea of how to write context-free grammar for the regular languages. And always remember, all regular languages are context-free language. Thank you all for watching the video.